So this is Nick Bond. He is with the Joint Institute of the Study of Atmosphere and Ocean at the University of Washington. I had to read that because there's a lot of words in there. So he's a climatologist. He's going to be giving us a seasonal outlook, and according to him, even a blind squirrel sometimes finds a nut.
Yeah, thank you. And I'm flattered to be invited back, especially. I think this metaphor, these metaphors may apply to my presentation from last year, but I am getting a little bit ahead of myself. What we're going to do here is review last year's weather briefly, a couple of topics involving the climate before we get into the outlook itself. I want to give a shout out to my old friend Mark Moore for kind of inspiring one of the little bit of research did on east winds in the Cascades. Wait a minute, old friend. Well, he is kind of old, so maybe that came out just right. And then we'll also talk about what we're seeing in terms of snowmelt in the Pacific Northwest in spring, and then finally get to the forecast, of course. All right, so what happened this past winter? It was a cold one, actually. Been a while since we've had something like that, and especially on the east side of the Cascades in the lower elevations, the Columbia River Basin, and in northern Montana. Those blue colors on the left show where temperatures below normal. In terms of precipitation, it was actually drier. That map on the right shows the precipitation in percent relative to normal, and so it was drier than normal on the west side of the Cascades and in the kind of, well, north part of Washington State, and wet, actually, in eastern Oregon. All right. So the circulation pattern that was associated with that, this is the geopotential height anomalies at 500 millibars, about 20,000 feet up in the atmosphere. It's what we use to kind of characterize the kind of regional atmospheric circulation. The blue color there shows where lower heights, lower pressure than normal. The oranges and reds, higher pressure than normal. This is actually a very unusual sort of configuration for an El Nino winter, which last winter was qualified, the weak to moderate one. And it actually makes sense that the circulation around that low that is centered off the northwest coast of California there, meant that there was more easterly wind anomalies, which means less westerlies than normal, and that makes sense that we didn't get as much precipitation on the west side of the Cascades as usual. It actually, in some ways, wasn't that different from the La Nina winter, the winter before. And one of the consequences of that I'm just going to, a couple of events to touch on before getting to some other stuff, but one of the consequences of that lack of westerly flow, not really any major floods. There's always some floods around here, and some rivers especially are flood prone, but this, for the Stillaguamish and the Chehalis River, it shows the peak flows each year going back, many decades, and it was kind of on the low side on both those rivers, and that was a pretty typical situation. One thing because we didn't have a lot of weather events, I don't know if anybody here is from the Port Angeles, Port Townsend, Sequim area, and so forth, but if so, you remember this storm that occurred in December, and if you happen to be up on Hurricane Ridge, it was might have been kind of interesting up there, but got a downslope windstorm and very strong winds, power outages, and warm temperatures associated with that. Okay, but this, let's go back to my first slide and the metaphors there. Now, this is the usual scene from around Seattle, but instead, this is what we had in February 2019, of course. And of course, there are snowstorms and snowstorms. A minor snowstorm, you can't get to work. A major snowstorm, you can't get to the liquor store. I was actually pretty well stocked, and so this event was the second most fun I had this past year. So anyway, just again, how remarkable it is, just what happened at Seattle. And this shows daily temperatures from February 1 through the end of March. And just this long string of below normal temperatures. We haven't seen that for a long, long time. It was the third coldest February we've seen, the snowiest one on record. We haven't had as much snow at SeaTac in any month for 50 years. So that's, if you look at the actual circulation pattern with it, and I've been doing some work kind of typing these and that sort of thing, we haven't had something like this since actually February 1989. So highly unusual. And one other kind of perspective on that, I direct your attention to just the top plots here. This is for SeaTac and Yakima, the last year, daily temperatures. And kind of day in, day out, it's warmer than normal. This is all relative to 1981, 2010. And, global warming, you may have heard about it and so forth. And so what actually really sticks out is just how unusual February and March were. So, yeah, great fun. All right, so again, I want to touch on just a couple of little climate tidbits before we get into the forecast. And here, I want to give credit to Mark to kind of inspiring a little bit of a quick look at what happens in, what keeps it snowy in the Central Cascades at relatively low elevations. Many of you know that Snoqualmie Pass has a ski area basically because those east winds bring in cold air from eastern Washington and have snow there at levels that you otherwise wouldn't get if you didn't have that source of cold air. And one of the questions is, as our climate changes, are we going to have less and less of that cold air kind of squirting through the passes, especially Snoqualmie Pass, but Stevens Pass also, and how is that going to affect, what conditions are like there. So what I've plotted here, just to prove to you that it really matters, what's happening in those east winds, if you just look at the temperatures in the free atmosphere, this is at a location, the Central Cascades, just east of Snoqualmie Pass at about 1,000, 1,500 foot elevation, that the air there is, and this is a time series, winter averages going back to 1982 or so, the air there up above the surface is actually typically above freezing in temperature, but the surface air, and this is actually based on measurements along the east slopes of the Cascades, the air right near the surface that's drawn into the passes is actually quite a bit colder than it is higher up in the atmosphere. And so except for 2015, there, a really unusual year, it's pretty consistently below that freezing line. All right. So what we were really interested in, Mark and myself and some other folks, is, again, the trend in this kind of easterly wind. And so what I did is using, I'm not going to go into the details, but made an estimate of how many hours there were both east winds and cold temperatures down near the surface to keep it cold in the passes. And this is a time series, again, going back to the early 80s, showing year-to-year variations. So that's this blue trace here. The numbers don't really matter so much. It's just kind of the relative, whether it's high or low or so forth. And then this is a special circumstance in which there wasn't necessarily freezing rain in the passes, but just when temperatures were cold at the surface but above freezing aloft and that potential. And the screaming message there is, at least in this 35, 38-year period or so, I don't really see any trend in the amount of east winds there. So that's good news. Whether that's going to continue or not, who knows? But at least so far, there's Snoqualmie Pass should be, the summit ski area should be happy about this. Another thing I want to just briefly touch on is spring snowmelt. Maybe some of you have noticed that the last few years the snowpack has really melted out fast. Another kind of complicated graph here. This dashed gray trace shows how much of the SWE at a composite 5 different places along the spine of the Cascades, from the 83 to present, that's last year. So this gray trace is how much snow water equivalent was at the end of winter, April 1 by definition. And then this blue trace is how much of that melted out in the 2 months of April and May. And so again, there's these last few years, there was relatively more snow melt than, you know, in the 2010 to 2014 time period. But I don't really see a trend in that either. The problem is that we know that snow melt is related to temperature. And so if you just look at the average temperatures for April, May, there along the horizontal axis, and the amount of water that melted out, essentially there's a really strong correspondence there between those two parameters. These years here, it was warm enough to melt more snow, but there just wasn't any snow there to melt out, especially in 2015. So as the climate warms, we can look forward to quicker meltouts, less of that late spring skiing that you know, some people really enjoy when the days are so long. And yeah, so anyway. All right, let's get to the forecast. Here's all the usual slide here about what the Climate Prediction Center, you know, blah, blah, blah. The one point worth making is that these forecasts are typically phrased in terms of in the kind of below normal, near normal, and above normal ranges, so a 3-tier system. It's got one of the sources of predictability we have is NSAW, El Nino Southern Oscillation, El Ninos and La Ninas. This top chart here in the upper left shows the probability as you go into the winter season, into spring, of near neutral conditions with the gray bars, which is the most likely thing. El Nino, maybe, there's a chance of that, but almost no chance of La Nina. And if you look at the individual models, that's what they're showing. Some are showing very near neutral conditions, others slightly above normal. A few are showing El Nino, but as a group, they're just showing probably the tropical Pacific, not different enough from normal to really affect our weather. What does affect our weather are the temperatures in the ocean off our coast. This is a sea surface temperature anomaly map from, well, first week of October or so. The yellow and oranges show where the sea surface temperatures are above normal. There is a relationship. It's not you know, really tight, but when there's cold water out there in October, the winter following, I here use Puget Sound, but for Washington State as a whole, it works the same way. The winter follows, when it's cold water, it never tends to be really warm, and when it's warm water out there in October, the winters are never really cold. 2018-19, because of February there, kind of is a little bit different from that general trend. If we look at what the sea surface temperatures are like out there right now, you'd have to expect a little bit on the warm side, but not extremely so. All right, the forecast itself, this is from the Climate Prediction Center. This is the official you know, temperature forecast. I've shown maps for 2 different 3-month periods, November through January, and kind of overlap January through March, so kind of early winter and late winter. And these orange colors show there's elevated odds of the temperatures being in that above normal category, but not a real strong indication. In terms of precipitation, and I'm a little surprised by this one, and I'll show you why in just a minute. It shows equal chances of it being kind of below normal, near normal, or above normal for both of those periods. And it turns out it's really difficult to make skillful forecasts of precipitation on seasonal timescales. But a couple of things that I think give me reason for guarded optimism is right here, is what we've been seeing in what the climate models as a group are showing, and in particular the tendency in the models that the runs made in September were, as a group, were showing kind of considerably warmer than, whether it's considerably warmer than normal. But the runs made in October are showing that to a lesser extent. And so the models as a group are backing off on the warmth. In terms of precipitation, again, recognizing that it's really hard to do, the US models as a group are actually, for this, it's for December through February, showing us on the wet side. The European models as a group, maybe less so, but still a little bit wetter than drier. But an important point to make is that when you look at the individual models, some are showing wet right over us. This one's dry, that one's not much of anything. And so there's a lot of variability, and moreover, a lot of variability from month to month. So I've been watching these, and there'll be a set of model runs. Oh, it's going to be really wet in December, and then they back off. No, it's going to be in January, and different models are kind of switching in and out. So it's probably even less predictable than usual. All right. So what's going to happen? All right. Like I was saying, we didn't really have any, kind of headline floods in the past couple of years, actually. That is part of our climate landscape, and I'd be surprised if we didn't have some major floods, at least on certain rivers this time. Here's hoping it's not, catastrophic ones, but that is something that we are seeing more and more of. Windstorms, wow, that's even more of a crapshoot than anything, but there's always that possibility, and it's been a while since we've had a really intense storm. So we'll see there. Cold air outbreaks. February 2019 came out of nowhere. We had about a week's notice that was coming, and highly unusual in the present climate. And so it's always possible to have something like that again, but pretty unlikely. I want to get down to here to the end of the season snowpack, and this is, actually, what you guys probably care about is snowfall and, temperatures within the winter, but from water resource managers, hydropower, agriculture, and the interests, what they really want to know is the end of season snowpack. And last winter was actually a little bit on the low side, I'm expecting, because maybe on the wet side and not probably not really warm, if at all, that we're going to probably have a little better snow season than last year. And I'm going to make a guarantee here that it's not going to be as bad as 14-15. In fact, if we have less snow on April 1, I'll eat a bug. I promise you, on the stage a year from, if there's less snowfall than 14-15, I bet I won't be invited back. But so. Anyway, please feel free to contact the Climate Office if we can be of help, and thanks.
I took that little shortcut right there. Great. Is there any questions for Nick? Oh, we got one over here. Is the mic coming?
Nick, I hope this isn't too personal, but how do you live with so much uncertainty in your life?
Say again, sorry, I didn't.
How do you live with so much uncertainty in your life?
Oh, yeah, that's right. Well, I don't even know how many toes I'm going to have, tomorrow morning necessarily. So the weather, it's just part of that. So. But you're right, and you have to have some humility and just the willingness to kind of put it out there and, okay, take your shots. Anybody else? I think it's,
You have another
people
question
are thirsty. Oh, there's another one.
Yeah. Oh, got a mic coming. Or over here. Yeah. You're getting your step count in. Awesome. Thank you.
I was kind of half expecting somebody to ask me what the most fun I had in the past year, and I wasn't going to tell you anyway. So, anyway.
So I've been conditioned to hear the blob, and they were talking about the blob. The National Weather Service was in early September.
Yeah.
How long are the effects of the blob? How long do they last? When they were talking about it in September, should I be concerned about the winter?
Yeah, it depends. This one really reached its peak in summer, and it turns out that the layer of water that's impacted by the conditions in the summer is pretty shallow, and so it can, if storms come through that cool it off, it can respond pretty fast. With the previous blob of 2014-16, that was a winter event, and it was a much deeper layer of water that was impacted, and plus there was kind of 1-2 punch in the weather patterns that helped reinforce it. And so this one is going away. The models do have it on the warm side up into spring of next year, but I don't think it's going to be a major player like it was in 14-15. Yeah, Mark. And I bet you can shout.
I was just wondering that, not that you're going to, but if you were going to, where would you buy a season pass?
I'm not as dumb as I look. I've found out that is something that is not a good idea to answer, but I have to, one thing, I was interviewed for a Portland TV station, and about the winter ahead and so forth, and I got actually a call from the guy who, Mount Hood Meadows, David something or other, and he kind of thanked me for the kind of care in which I provided that forecast, and all the caveats and that sort of thing, because, yeah, like you said, I've been bit a few times.
What was your most favorite fun thing?
Yeah, like I said, I'm not telling. Forget it. So, beer time.
Thank you, Nick, so much.